Okay, so for 4.2, we are going to look at how to use the summation formulas for a few questions. So one of the things that we have to recall from pre-calc, you ended up proving these. So let's talk about the summation as I is equal to 1 to n from a constant. This is just equal to whatever the constant is times n. Now, an example of that would be the summation of I is equal to 1 to 5 of any number. Let's go ahead and say 3. So what that means is the first term, I sub 1, would be 3. I sub 2 would also be 3, 3, 3, and 3, because that subscript there, and again, this case just means n is equal to 5, so I have 5 terms, and that just means it is equal to 3 times 5. But the general formula is one that we're going to go ahead and use. All right, the next general formula that we go ahead and need is the sum, again, from I is equal to 1 to n of any number I. That sum is n times n plus 1 over 2. Now, an example of what that means, we're going to do the same thing. We'll use the same numbers. We're going to go from I is equal to 1 to 5 of I. So the first term, I1, is equal to 1. The next term, I2, would be plus 2, then plus 3, then plus 4, then plus 5. You have 5 terms, and that sum is equal to 15. Now, if we want to go ahead and look at the formula, now if I were to plug that back into the formula, that formula would just be, and again, n is equal to 5, so that formula is just 5 times 5 plus 1 all over 2, or 5 times 6 divided by 2, which is still 15. You prove these in pre-calc for using math by induction. All right, so there's 2 more that we need for this section. Those 2 are going to be the summation when I is equal to 1 to n of I squared, and that is just equal to, I'm going to rewrite the way I have that too, I don't like it. That is just equal to n times n plus 1 times 2n plus 1 all over 6 . Another one you need for this section is I is equal to 1 to n of I to the 3rd power, which is equal to n squared times n plus 1 quantity squared over 4. Now you can go back and prove all of those by induction. And you should have done that in pre-calc. Now, it's really important to remember what we're talking about as far as when we're talking about I. I is the index of the summation formula, and it's just a placeholder. It tells you what term it is, and you're plugging that value into the formula. Now we're going to go ahead and take and use all of those. Okay, so if we look at question 22, and this is in section 4.2, they give us the summation of j is equal to 1 to n of 7 times j plus 4 all over n squared. Now, when you're looking at this, n, in this case, is a constant that you can go ahead and pull out. And the reason for that is our variable of our summation, our index, is j. Everything else, I can pull that out as a constant. So that gives me 1 over n squared of the summation of j is equal to 1 to n of 7j plus 4. Now, in order to use the summation formulas, I want to go ahead and separate those out. So that's 1 over n squared out front. And this is the summation of j is equal to 1 to n of 7j plus the summation of j is equal to 1 from n of 4. Now, this 7 here is a constant. It also can come out front. And this 4 is also a constant. So what I want to go ahead and do is break those up. So I'm going to break that down a little bit more and make that 1 over n squared times 7 summation of j is equal to 1 to n of just j plus the summation of j is equal to 1 to n of 4. Now, the reason I didn't pull that 4 out is because that's the constant formula, and now I'm going to use those summation formulas. The first one, all of this inside here, I get to replace because the summation of any index from 1 to n of a variable, when the index and that variable are the same, is just n times n plus 1 all over 2. And the next one is the summation of that constant. So that would just equal c times n. So knowing that, what I have is 1 over n squared on the outside. This becomes 7 times n times n plus 1 all over 2 plus 4n. Now I just need to go ahead and simplify this. So I'm left with 1 over n squared. I need to find a common denominator inside here. So I multiply out the numerator here, and I get 7n squared plus 7n all over 2 plus, I'm going to go ahead and I want a common denominator here, so I'm going to multiply that times 2 over 2, and then I'm going to get that as 8n all over 2. Now I combine everything and pull the 2 out, and I'm just left with 2n squared in the denominator. And back up top in the numerator, you have 7n squared plus 15n. Go ahead, factor out an n, then you're left with 7n plus 15 all over 2n squared, or just 7n plus 15 all over 2n. Now, if we look at what the book is asking you to do, they're asking you to also to use your calculator to find out the fact what happens when the sum, when n is equal to 10, when n is equal to 100, n is equal to 1,000, and n is equal to 10,000. So all you're doing with those is you're plugging them in. What you get with that is you get the sum would of 10 would equal 4.25. For the next one, it would be the sum up to 100 would equal be 3.575. The sum of up to 1,000 is equal to 3.5075. and the sum of 10,000 is equal to 3.50075. Now what we're really doing here is we're getting ready to take this limit as it goes infinity. So a little preview. Of the next section, 4.3, the limit definition of infinity. Let's go back to what the sum was equal. The sum of all of this was the sum to n. So if I go back up there and take that value, the limit as n approaches infinity of 7n plus 15 all over 2n. What I want to do is break apart this fraction, and I get the limit as n approaches infinity of 7 over n 2n plus 15 over 2n. Those n's cancel out. This n in the denominator gets infinitely small and goes to 0. So this limit as all of this approaches infinity is 7/2, which if you'll notice, even when n is 10,000, I'm already getting very, very close to that.